Hey everybody, this is Miss Smith. So today we're going to talk about the law of sines. Now, I know you're probably already like, Miss Smith, this is not a math class. Okay, what we're going to be doing pretty much for the rest of this unit is we're going to be taking math principles and applying it to physics concepts. So, I mean, you'll get it, it's fine. Now, law of sines and law of cosines, I normally actually teach that before Coach Johnson gets to it. So if you're currently enrolled in Coach Johnson's class, you'll get this again a little bit later. But I'm normally the one that kind of helps you through it. And so by the time you actually get to Coach Johnson's class, you're like, oh, okay, I get it. I know this. So this is great. But anyway, it's actually not too difficult. It's what happens is there's quite a few letters that are involved and people get kind of scared of it. It's really not that bad. So you may be a little bit of deer in the headlights today. You may be scared about it, but it's okay. All right, if you start getting into some of the practice problems and you don't know what to do, like you start guessing on how to do something, just stop what you're doing and send me a message. That's all that you have to do. Okay, so today we're going to talk about the law of sines. Okay, so this is going to be for non-right triangles. Now, the whole purpose of us learning this mathematics skill is pretty soon we're going to be in a place where there are no written formulas, and you have to look at a situation and decide how it's going to be calculated. So if I give you this skill set now to be able to make these decisions, then when those problems do come up and things start getting really difficult, you'll be fine because you know how to do it. So this is to help you. This is in an effort to help you. Now, I'm going to go ahead and draw a triangle. And I'm going to show you how to label this triangle. Now you notice that this is not a right triangle. Okay, so I'm going to label this with 3 different colors. So I'm going to start with purple, and let's make A purple. So, oops. So let's make this angle A. So now remember, these are set up to, the angles are opposite of the sides. Just like when you do sine, cosine, and tangent, you have opposite sides and adjacent sides. Law of sines works wholly on opposite sides, not adjacent sides. That's the law of cosines. So this is all about opposite sides. So the side that is opposite of A is this one here. Okay, so we're going to call that A. That's a lowercase a, because angles are capital letters and sides are lowercase letters. That is important when I write the law of sines here in just a minute. So let's label B in red. So we're going to call this angle B. So the side opposite of angle B is this one here. That's opposite, straight across. And then C, we're going to do in blue. So this is capital C for angle C, and then this is a lowercase c for side C. Now, let's go ahead and let's write the law of sines. So sine of A, so angle A, over side A is the same as or equal to sine B, so angle B, over side B, which is same as or equal to sine of angle C over side C. Now notice that these are all capital letters. Let me make this C a little bit bigger. These angles are all capital letters, and the sides are all lowercase. This is important, okay? So this is actually a good formula. I may actually take a screenshot of this and send it to y'all, because this is good. Anyway, all right, so let's try this thing out. This is from our notes yesterday. So this is helpful. Okay, now, you always hear your teacher talk about how side-side angle doesn't exist, okay? It does exist, but it's a difficult case, okay? Because of the way the information is, there's a lot of room for error. So that's the reason why the side-side angle is called an ambiguous case, is because there's a lot of room for error. So there's even a possibility to have a totally separate triangle with different values than what you're trying to calculate. Like, it's bizarre. You could have the same situation. It's weird, okay? So we're not going to do anything with side-side angle because you will most likely not come in contact with that situation. So we're going to move on. So we're only going to learn angle, angle, side, angle, side, angle, side, angle, side, and side, side, side. So those are the four that we are going to go into. And so this is how we use law of sines or law of cosines. Now, there is a possibility that you could use side, angle, side. You could use law of sines with it. That is a possibility because law of sines is a little bit easier than law of cosines. You could. Specifically trying to find an angle, it's easier to use that than trying to find an angle with law of sines and law of cosines because law of cosines formula is super long. So let's go ahead and let's label this thing. So I'll try to stay with the colors that we chose. So this is angle A. This is angle A. So this means that this is side A. Angle B. Technically, really, any of the angles could be A, B, or C. It really doesn't matter. The fact of the matter is, what you've really got to pay attention to is that your angle corresponds with the correct side. That's the biggie here. So don't fret over labeling, okay? You could be any configuration that you want. It could be angle alpha or something crazy like that. It doesn't matter as long as you have the corresponding side to go with it, the side opposite. It'll work. Law of sines will work no matter what, as long as you have the correct side, the opposite side. Okay, so that's angle B. This will be lowercase b for side B. And let's make this capital C with a lowercase c. Now, I'm going to erase a few things, and I'm going to give you some values. Okay, so I'm going to erase this here, and I'm going to put in some values. So we're going to make this 50. We're going to make this 20. We're going to make this 25. Okay, so you have an angle that's unknown. Okay, you have two angles here. Most of the time when you're dealing with law of sines, you'll have two angles, and you still need to find the third. So anytime I give you a problem like this, I'm going to ask you to find every unknown. So this particular triangle has three unknowns. I've got one here, side A, side C, and angle B. So you would have to solve for all three of those. Okay, so the first thing that you do, if you've got two angles, the easiest thing for you to do is to solve for that third angle. So you know that all of the sum of all the angles inside of a triangle are 180 degrees. So if I've got two, I can find the third. So 180 minus 20 minus 25. That is 135, I believe. Calculator. 180 minus 20 minus 25. I think it's 135. Yes, it is. This is 135. Okay, so that's what goes here. Okay, now, under normal circumstances, I don't want to say normal circumstances. What I mean is, whenever you solve for an angle, that is kind of an irrefutable piece of data that you solve for. Like, 180 minus the two angles is guaranteed to be the third angle. Excuse me. So technically, when I say don't use a solved answer to find another answer, I'm not talking about this angle that you did, because this is irrefutable data. It will always work, okay? So that doesn't count in the situation I'm about to tell you. What I am going to say is, let's say that you solve a side, that you find a side, and let's say that that value was, side A, that you solved for side A, you found side A. You would not then use the value for side A in your calculation to find another side, okay? The reason why you don't do that is because when you solved for side A, you rounded your end answer. So if you put a rounded answer into another calculation, your end calculation will be way off, okay? So do not use a solved answer in the law of cosines equation. Okay, now, technically finding that third angle for subtracting from 180, that's the exception to that rule. That's okay. like that's guaranteed to work because it's irrefutable. Like, yes, that is 180 minus the 2 angles will always equal that third angle. We know that, okay? So now what I've got to use is I do have to use the information that I have. So I've got to have, according to my law of sines here, I've got to have an angle and its corresponding side. The only one that has the angle and its corresponding side is these two here. So that's how I'm going to write it. So I'm going to say sine of 135 divided by 50 is equal to, and let's go ahead and let's solve for C. So let's do this here. This angle with this side. We're going to go ahead and do this. So I don't know that side, but I do know the angle of C, which would be 25, but I don't know that side, so I'm just going to leave it as a lowercase c. Now, this is a proportion, technically. So I'm going to cross multiply right here, and that's how I get C is C sine of 135. I'm going to cross multiply again. So that's going to be equal to 50 sine of 25. All right, now I only have one variable that I need to solve for. So I need to get C by itself. So I'm going to divide both sides by sine of 135. So this goes away completely. So C is equal to, now let's put this in our calculator. Go to our calculator. So 50 sine of 25. And then go ahead and hit enter, okay? Do not write this down. This is just, you know, we have to do this in a certain process in the calculator. Without it, does it get confused? So the easiest way to do this, to make sure that your answer is correct, that you don't accidentally divide or multiply the wrong thing, is that you do it in steps. So I get that final answer for the top of that, the top side of that, and then I just divide it by the bottom. But I leave it in the calculator without rounding. So all I'm going to do is I'm going to do 50 side of 25. It gives me this number here. I'll hit the division symbol, which will take the answer from the previous question, and then I can divide that by sine of 135. Hit enter. Now, all of your answers for law of sines and law of cosines will just be whole numbers for now. We will eventually get into where it won't be, but to just make things easier, make your life easier, we're going to round to the nearest whole number. So the nearest whole number for this one is 30. Okay, so we said that side C was 30. And that makes sense, actually, if you look at your calculation, because this is the longest side, and that's 50. This is the second longest side, so that's 30. So this one should be less than 30 because it's smaller. Okay, so I'm going to erase this so we can solve for side A. Now, this is what I was talking about. Do not use a solved answer in the law of sines. This is an answer that we just calculated. You would not use 30 and this angle in the law of sines. You're still going to use these two. So you're going to do sine of 135 divided by 50, which is equal to sine of, I forgot what we're doing, 25 over C. Did I solve for C earlier and I completely just, hold on, let me check. I did solve for C because I used 50 sine of 25. Okay, well, excuse me, I labeled this wrong. Okay, so C, no, we did solve for C, excuse me. We did solve for C. We did find that. C does not equal to C. I'm having a massive brain fart. C is equal to 30. There we go. Okay, so we need to solve for A. All right, so this angle is going to change, and this label will change. So this will be sine of 20 over A, because we're finding this. Okay, so we've got to use these two to find these two. All right, so we're going to cross multiply. We get A sine of 135 is equal to 50 sine of 20. So you divide both sides by sine of 135. And so go to the calculator, 50 sine of 20, 50 sine of 20. Hit enter, divide by sine of 135. Hit enter, 24. And we were correct about that. Okay, we said that side A would be the shortest of the three. That is correct. All right. So right now I want to identify just very quickly what type of angle, what type of triangle this is. This value was given as well as this value and this value. So technically this is an angle side angle. So now let's do the one for angle side. So let me draw another triangle. Nope, I don't want a red triangle. I want a black one. Oh, that's terrible. Try again. Nope. Okay, good enough. All right. So let's go ahead and let's label this thing. A, B, C, C. Okay, so let me give a couple of values here. So I'm going to erase a couple of them so that we're doing, what are we doing? I forgot already. Angle side. Okay. So let's make this 70. Let's make this angle 40. Let's make this angle 35. Okay, so technically this counts as an angle. So here's an angle, and there's a side. Had this A been known, it was angle side A, and then another angle, that would have been angle side angle, but this is angle side. Okay, so let's go ahead and let's solve for the angle here, angle A. So angle A is equal to 180 minus 40 minus 35. So I think that's 105. (180 minus 40 minus 35). 105. Okay. So now we're ready to do, so this is 105. So now we're ready to find, let's find side A. So we're going to do sine of, now here's where we've got to choose which one we're going to do. I've only got one side that's given. So I've got to have one, because remember we always have one where everything's given. So we've got to have one of these where everything's given. There's not going to be a variable. So I'll only have one side. So that means I have to use this one. So it's going to be sine of 35 over 70 is equal to sine of, we're going to do side A, so sine of 105 over A. Cross multiply, you get A is equal to 70 sine of 105 divided by sine of 35. Okay, in your calculator, so 70 sine of 105 divided by sine of 35. Okay, round to the nearest whole number, that's going to be 118. Okay, so let's find side B. So B is equal to, well, let's not do it like that. Let's just do this other one first. Okay, so we're going to use side B, so we're still going to do sine of 35 over 70. It's equal to sine of angle B, which is 40, divided by B. Okay, cross multiply. B is equal to 70 sine of 40 divided by sine of 35. Okay, so new calculator, that's going to be 70 sine of 40. Divided by sine of 35. Oh. Okay, so 78. Okay. Now, there's one more scenario that you will be given that's kind of a challenge one. What happens if you've got to find an angle? Okay, let's say that you've been given all three sides and one random angle in the inside, and you're asked to find the other two. Okay, so let's try that scenario. Okay. All right, so let's go ahead and I'm going to give you some values real quick. Let's say that this is 20, this is 5, and this is 15. And then you're given this random angle right here of, say, 120, just to make things easy. Okay. So this is all the information that you're given. You're presented with this exact. It's not labeled at all. Okay, you'll be asked to do some of those that aren't labeled at all. And you are asked to find this angle here and this angle here. Okay, ignore the little divot right there. That was, my bad on drawing a triangle. Anyway, so you can still use law of sines on this, even though this is technically a side angle side or side side side. Since you're finding angles on the inside and you have at least one angle on the inside, technically this is side angle side because you've got one angle on the inside. You can use law of sines for this. And it's easier to use law of sines for this. Now, had this angle not been here and it had just been three sides, definitely law of cosines. All right, so let's go ahead and solve for these angles. So I'm going to do sine of 120 over its corresponding side, which is 20, is equal to sine of I don't know what. Okay, I'm just going to put x because we never assigned what the angle's called. Could be A, could be B, could be alpha, could be theta. I don't care. I'm just going to call it x, okay? Over, so we're going to do this one. This is the one that I'm working on right here. We're just find that angle there. So the side opposite of that is going to be 5. Okay, so I'm going to put a 5 down here. Cross multiply. 5 sine of 120 is equal to 20 sine of x. Okay, divide both sides by 20. Okay, that goes away. You're still, it's this. Let me rewrite this. Equal to sine of x. Okay, I'm not looking for sine of x. I'm looking for x. Okay, so I have to divide both sides by sine. Okay, this is kind of ridiculous to put in a calculator. So the other way to write this, because technically that's inverse sine, because it's on the bottom side of a fraction, is like this. With a -1 out there. And that gives me x. But here's the problem. Put this dang thing in the calculator. People struggle with this when trying to put it in the calculator. So here's how you write it in the calculator. Exactly how you put it in the calculator. So the calculator doesn't miscalculate. Yes, you got to have both parentheses there. 5 sine of 120, close parentheses, divided by 20. Okay, you've got to have that interior parentheses there. You've got to have this interior parentheses around this, or it will be calculated incorrectly. It will calculate it as 120 divided by 20 into sine itself. So don't do that. Okay, so let's go to the calculator. Let's do this in the calculator. Watch the buttons I push. Second sine. That's how you get that inverse sine. So, oh, I forgot what it was already. 5 sine of 120. 5 sine of 120. Now, did you notice that in the equation, after I did inverse sine, I put regular sine in the equation? Because that's what I have. That's what's here. This is regular sine. That is not inverse sine. Okay? Follow exactly what it says. So, close parentheses, divide by 20, I think it was. 20, close parentheses, enter. Nearest whole number is 13. Okay, so this is 13 degrees. Now, what I can do, because remember we talked about it's okay 180 minus 2 angles will always equals that third. It's okay that we do that. Okay, so we're going to do 180 minus 120 minus 13, and that will be come on, calculator, 180 minus 120 minus 13, 47. That's anything here, 47 degrees. Oh, there's the bell. Okay, if you're still stuck on this, I hope that you feel better about this now that I've gone over it with you. But if you're still stuck on it, let me know.